Here's the video I promised where I will go through number 25 on the review, the review for test 7B. And then after I go through problem number 25, I will also open up the take-home test and talk through the take-home test. Fred is going to invest $18,000 in an account that pays 4.2% interest compounded continuously. First of all, we're going to answer, how much will Fred have in 6 years? We already know how to do that. That is going to be very similar to a problem we did in class when we reviewed for the test, which was yesterday. And this first part is going to be very similar to number 1 on the take-home test. So the key is compounded continuously. Ooh, my highlighter is going crazy here. All right. The minute you hear that, you should be thinking this. PERT. P is the amount Fred is investing. R is the interest rate written as a decimal. Remember, it's 4.2% as a decimal, 1, 2. You move it 2 places to the left, 0.042. And T is 6. So we plug it in. We have 18,000 E to the R T. And now I'm going to plug that into my calculator. And I don't need to be in this spot. So let's get out of there. Okay. 18,000 second ln gets me my E, 0.042 times 6. Now let me explain something. Because on my calculator, my exponent pops up like this, I don't need my 0.042 and my 6 in parentheses. If you have a calculator where it doesn't pop up but stays level with the E with a upside down caret, you must put this in parentheses or it will not work. You won't get the right answer. And there's our answer, $23,158.73. There's my dollar sign, 23,158.73. There is my answer to the first part of the problem. The second part of the problem is a little more tricky because we're solving for how long will it take for Fred's money to double. So we're solving for T. And so I'm going to show you 2 ways to do part 2. One way, algebraically. And another way, we're going to check our answer by using our calculator. So I'm going to scroll down here now, if I can. There we go. And we already know that Fred is investing $18,000. Well, we want to know how many years is it going to take him to double his money? Well, doubling 18,000, well, that's just taking 18,000 times 2. We want to know how long is it going to take for Fred's money to be worth 36,000. We're still using PERT. P is still 18,000. R is still this, but we don't know T. That's the mistake students were making on this. They were plugging in 6. We don't know T. But guess what we do know? We now know A. It's 36,000. So if I plug that in, I get 36,000 equals P E to the R. Ooh, what does this look like? To me, It looks like an exponential equation, and we want to solve for t. Oh, you know what? I know I have to do something. I have to get that t in front. So I have to play baseball. But the only way I can play baseball is if I have a log or a natural log. Well, we're dealing with e, so obviously we need a natural log, but I can't natural log that e because the 18,000 is in the way. So I'm going to divide both sides by 18,000 right now. So 2 equals e to the 0.042t. Now I'm going to ln the left side. I'm going to ln the right side. Perfect. Baseball. Oh, you know what? ln of e, that's 1. Let's show you. If we type in second ln, that's not what I wanted. ln, now I want second ln to the first. That's 1. And actually, I should have caught it way back here because look what we're doing. We're ln'ing an e. I could have just canceled those and brought down the 0.042t. Doesn't matter. Either way. All right. Now I'm going to divide by 0.042. Divide by 0.042. T is equal to ln of 2 divided by 0.042. About 16 and a half years. That's my calculator. Pen. 16 and a half years it's going to take to double Fred's money. Let's do this on our calculator now. So here's the deal. We know we're looking for 36,000. That's our A, which is going to be like our Y value. So if I plug this model, 18,000 e to the 0.042t into my calculator right now, we should get about the same answer. Y equals, we have 18, 1, 2, 3. Come on. There we go. Second ln, 0.042x. So if I graph that, I'm not going to probably see anything. This is still turning. Okay. It's exponential. So on an exponential graph, we always hit zoom 0, always with exponential growth or decay. And there we go. Exponential growth. That's what we're dealing with here. Now, second graph. Aha. Look at this, you guys. If I scroll down, after 16 years, Fred's money is worth $35,247. I want to know how long it's going to take to get to 36,000. So there it is, 17. So the calculator gives us an approximate answer. Algebraically, you get the exact answer. It's actually in 16 and a half years. So we use our calculator to check our answer there. All right, let's open up the take-home test. Number 1, I'm not even going to read it. It's very straightforward. We did a problem like this yesterday in class, and part A of the Fred is just like this, asking for the total amount of the investment. Number 2 is just like I did on part B. They want to know how long it will take for Callie's money to double. So yes, I would like you to do this algebraically and then use your calculator to check your answer. And number 3 is a graphing problem. Remember, I don't know if it's going to let me write on here. Nope, it's not. Oh, wait, maybe it will. Haha, it might. It does. Okay. When you are graphing, you have to graph both the parent function and the transform function. As you can see by looking at this, from going from here to here, we're going to the right 2 and down 3. So after you graph it, make sure that that's down 3. Make sure that's happening. For both of them, you need a y-intercept. You need the asymptote for both. And obviously, they're going to be different. And you need one additional point for each. One extra point. I usually use, like I did in class, x is 1, find the y value. And the y-intercept, obviously x is 0, find the y value. You can graph them both right here on this graph. Let me know if you have questions.